This is the second in a series of 4 short videos that will help you decide which specific hypothesis test to use when faced with a free response type question that needs a hypothesis test. In this video, I'll use examples to demonstrate how to apply the rules that I discussed in the first video. None of the data presented in any of these examples is real data. A recent study found the mean income in my hometown to be $60,543 with a standard deviation of $5,224. The mean income in the U.S. is reported to be $45,000. Do the people in my town earn more money than normal? First, we want to look at the variables. I see only one variable, income, and it's quantitative. We're not concerned with a difference in incomes, so each observation is a single number. A recent study means that we have only one sample. So we have one quantitative variable. Each observation is a single number, one independent sample. This means we use a one sample t-test for means. A doctor believes that over 25% of teenagers smoke. A recent confidential survey of 1,000 teenagers found that only 174 admitted to smoking tobacco regularly. Is this evidence that the doctor is wrong? I see only one variable, smoking status. It's categorical with only two categories, either you smoke or you don't smoke. A recent confidential survey indicates that we would have only one independent sample. One categorical variable with two categories. Two categories tells us that we'll be dealing with proportions. One independent sample means that we will be using a one sample z-test for proportions. Who drives faster, men or women? A random survey of 584 men found that 385 had been ticketed for speeding, while a similar survey of 1,038 women found that 642 had been ticketed for speeding. This seems to have two variables, gender and whether or not someone has been ticketed for speeding. But if we look closer, we see that we have one sample of men and an independent sample of women. So each person surveyed was only asked about whether or not they've been ticketed for speeding. So we have only one categorical variable. It has two categories. They've either been ticketed or not ticketed. We now have two independent samples. So this is a two-sample z-test for the difference of proportions. Who has the best pizza, chain A or chain B? Randomly selected patrons of each chain were recently asked to rate their favorite pizza from that chain on a scale of 1 to 10. I see only one variable, pizza rating. It's quantitative. And each observation is a single number. Each person was asked to rate their favorite pizza. We have randomly selected patrons of each chain, and we have two chains, so we have two independent samples. One quantitative variable. Each observation is a single number. Two independent samples. We use a two-sample t-test for the difference of means. Who has the best pizza, chain A or chain B? Randomly selected pizza lovers were recently asked to rate their favorite pizza choice from each of the two chains on a scale of 1 to 10. This problem seems very, very similar to the last problem, almost identical. The differences here are in the samples and the observations. In this example, we have only one sample, randomly selected pizza lovers. Each person was still asked to rate their favorite pizza, so we have only one variable and it's still quantitative. But now each observation is the difference of two related numbers because each person rates their favorite pizza from each of the two chains. So each person gives us a rating for chain A and a rating for chain B, and we're interested in the difference of those ratings. So we have one quantitative variable. Now our observations are the difference of two related numbers, one independent sample. We use a match pairs t-test for the mean of differences. According to the State Horticultural Society, Central North Carolina trees are 35% pine, 23% oak, 12% spruce, 7% maple, and 23% other. Janice just bought property outside Chapel Hill and surveyed her trees. She found 10 pine, 3 oak, 1 spruce, 4 maple, and 2 pecan trees. Is Janice's property unusual? We have only one variable, type of trees, and it is categorical with 5 categories. I see only one sample. Janice surveyed her trees. I see no other surveys. So we have one categorical variable with 5 categories. That means we must be using a chi-square test. We have only one independent sample, so this is a chi-square goodness of fit test. A random sample of high school seniors found that 103 of 245 girls and 118 of 312 boys planned to major in STEM-related fields in college. Is there a significant difference in interest in STEM fields between high school girls and boys? This looks very similar to the example of men and women speeding. But now, instead of 2 independent samples, we have a random sample of high school seniors. Each person sampled was asked to tell us their gender and their planned major in college. So that's 2 variables. They're both categorical. So now we have 2 categorical variables. Regardless of anything else, this must be the chi-square test of association, also called the chi-square test of independence. We'll never have more than one sample when we have 2 variables in AP statistics. And notice, the number of categories is not relevant because if I have 2 categorical variables, it must be the chi-square test of association regardless of the number of categories in the variables. In this particular case, each of the variables has only 2 categories, and so this problem might look very much like it should be some type of test of proportions. But since there are 2 variables, it must be the chi-square test of association. A random sample of 1,000 registered voters from each of 4 regions in the U.S. recently looked at political party affiliations, Democrat, Republican, or Independent. Are political party affiliations similar across the U.S.? I have only one variable, political party affiliations. It's categorical with 3 categories, but I have 4 independent samples, a random sample from each of 4 regions. 1 categorical variable, 3 categories, 4 independent samples. This is a chi-square test of homogeneity. 38 college freshmen eat a handful of M&Ms. They each record the number of M&Ms they eat, and 1 hour later, researchers test their blood sugar levels. Is there evidence of a relationship between amount of candy eaten and blood sugar levels in young adults? I see 2 quantitative variables, number of M&Ms and blood sugar levels. 2 quantitative variables means this must be a linear regression t-test for slope. 2 quantitative variables. Notice, again, we have only 1 independent sample. There were 38 college freshmen. Whenever we have 2 variables, we'll never have more than 1 sample in AP statistics. The type of observations is not relevant. In this particular case, each of the variables is a single number, but we could just as easily have looked at the blood sugar level before eating the M&Ms and after 1 hour later, and looked at the difference in those blood sugar levels and compared that, or made a scatter plot of that versus the number of M&Ms eaten. So both variables could be the difference of 2 related numbers, only 1 variable, or neither variable. It doesn't really matter. Whenever we have 2 quantitative variables, we will use linear regression t-test for slope. This slide shows the specific function on your TI-83 or 84 calculator that you would use for each of the 9 hypothesis tests that I talked about in this video. Feel free to stop the video and take a screenshot of this slide if you would like to keep it for later reference. If you have any questions, for a fast response, email me at apstatstutor25@gmail.com, or you can post your question in the comment box below. If you're interested in tutoring, I offer one-on-one, either in person or online. Contact me again, apstatstutor25@gmail.com. If you found this video to be helpful, please like the video and tell all your friends about me. Thanks for watching.